Okay, welcome to Chapter 2, and in this chapter our focus is mainly going to be on descriptive statistics revolving around these things called frequency tables or frequency distributions, and looking at some graphing presentations like bar graphs, pie charts, and histograms. Okay, so here is an example of what they call a frequency table, and I'm just going to make a couple comments. They say that this is a grouping of qualitative data, and I just want to make this clear. I don't want you to be too concerned with, oh guys, this is qualitative. How do you group quantitative data? It's the same basic idea, except for the quantitative data, they call it a frequency distribution. But if you look down here, the basic idea here is you've got basically, here's a class, and over here here's the frequency count. And this one shows in terms of vehicles sold by location. So if you looked at, for example, Kane sold 52 cars. Olean sold 40. So it basically is summarizing some data into a more meaningful content, which is a descriptive statistics. And this is the first one. It's called a frequency table. The next one is a pretty obvious illustration of a descriptive statistics. This is called a bar graph, and this is using the previous PowerPoint slide. Rather than putting it into a table, they basically put it in terms of a bar graph. Likewise, you can use bar graphs. You can also use what they call pie charts to present data. And later on, I'll give you an example of how pie charts are used exactly. But typically, pie charts are used to show percentages or proportions of data. And by the way, because percentages is a heavy way or a very popular way to collect data, pie charts might be a pretty common useful tool to help you represent the frequencies in your example or in your sample size. So the next couple slides walk you through just an example of how a bar chart or how a pie chart might be used to summarize this information. Notice there's 4 categories, and here are the frequencies that are presented for each category. And then in the next slide, they're going to show you how you might want to organize that into a bar chart or a pie chart. Okay, so here's an example from the previous slide showing you the frequency table, and this is the relative frequency. And notice that the frequency table is used with the bar graph, and the relative frequency, which is kind of like your percentages, is used with the pie chart. So in a moment, I'm going to show you how they came up with these. But for example, so for your frequencies, if you took these totals right here and came up with one total for all your frequencies, so you'd add up the 102 plus 58 plus 30 plus 10, that's going to give you 200. And then what you do then is you take each one of these individual classes and you divide each number by 200. So I'm going to write it up here so you have some room to see it. So if I were to take 102 and divide that by 200, that's going to give me 0.51. If I took 58 and divided that by 200, that's going to give me about 0.29 and so forth. So again, you take each one of these and you basically divide them by 200, okay, and because that's your total. And then here you get your total relative frequencies. And I'm going to add this. You should always be able to add up your total relative frequencies, and they should always equal 1.00. But that's basically how you do it. And as I said before, here is a frequency distribution, and you'll notice that they talk about this being for qualitative data, but you notice it's the same idea. You simply have a class area. In this case, it's presented in numerically, and then over here you have a frequency count, but it's basically the same idea. Is that you're presenting data to make it more meaningful, but this is basically called a frequency distribution. And just to kind of give you some specific terminology about this one, so if you come across something called a class interval, notice that'll be the difference between, for example, the 200 and the 600, so that would give you basically 400. That's called an interval. The class frequency would be basically adding them up and putting the frequency counts that correspond to each of these levels. And then there's something called the midpoint. So for example, to get the midpoint, you would take 200 plus 600, which is 800, and divide by 2, and that would give you 400, and that's how they basically came up with that midpoint. And you can do that basically for each of these. So you'll see that coming up where you may need to be able to calculate a midpoint for each of these classes, because you may need it later on to do some averaging and some standard deviations of what they call group data. And then in the next couple slides, I'm going to walk you through how they came up with determining what should be the class width and how many different classes should they come up with. And so using this as the example, there's 180 vehicles that were sold, and this is just a random selection. And you'll notice that this particular slide is always showing you they did a max, the maximum number, and the minimum number in terms of the profit that was made on each vehicle sold. And then we're going to take this information in the next couple slides and show you how you can take this and convert it into a more meaningful frequency distribution. And so one of the first things you do is to try to figure out exactly how many classes you would need. And one of the little tricks is a little formula where you take 2 to the k greater than n. So n represents the number of vehicles that were sold. So once you start to go, and this is basically trial and error, you'd go 2 to the 1, you could go 2 to the 2, and you keep going until eventually you want to get just past the 180. So down here what happens is when they went to 2 to the 7th power, that got to be 128. Notice you want to be more than 180. And then when they went to 2 to the 8th power, that got you to 256. So because 8 was just past 7, they're going to suggest that you use 8 classes. So you can use this as a little bit of a trick to determine just how many classes you need. And I'll kind of stress, it's still very subjective. There's no really right or wrong, but this is a useful tool to help you summarize the data. Okay, now, once you determine the number of classes, then the question is, what should be the interval width? So what you then do is you take the largest number, the maximum number. I'm going to write that right down here. So this was the maximum number. You subtract out the minimum number, which is the smallest, and then you divide by the number of classes. So in this case, when you did that, you got about 374.75. And based on how the numbers were presented, they just said, well, why don't you just round, in multiples of 10 or 100? So rather than saying 374.75, they're just going to say, hey, let's just use 400 as our interval. So you can see that there's some subjectivity to it. There could be a little bit of a judgment. And in some cases, there's really could be multiple correct ways on how to put together your distribution. And finally, you can see this is what they kind of came up with. If you count them, here's 1, 2, 3, 4, 5, 6, 7, 8. There's your 8 classes. And they figured, well, let's just start with 200. And they went up to 600 and so forth. And this is basically how they grouped it. Obviously, they're showing you somebody had to actually count how many go into each category. And then, as you can see down below, you can see what they came up with. So you've got your frequencies right down here, and notice it all adds up to 180. Now you notice the next step, eventually you'll see in the next couple slides, is what they will do is they'll take these frequencies and then they'll convert them into what is called a relative frequency. And so like in this example, you would take 8 divided by 180. You take 11 divided by 180. So again, you take each one of these, divide it by 180, and you're basically going to convert it into a decimal format. And again, that is called a relative frequency. And this is just kind of going back to some previous slides that they had showed you. I think the first one, this was the frequency table with the cars sold by type. And notice here's your frequency count right here. And then here's your relative frequency. And again, the way they would have come up with these numbers is they would have taken 52 and divided by 180, and they would have gotten about 0.289. If they took 40 and divided by, here it goes, 180, you would have gotten 0.222, okay? And you're going to find generally for me, even though they took these out to 3 decimal places, if you ever rounded these to like 0.29 or 0.22, eventually, you're going to find that, at least with me, when you get to an exam, usually 2 decimals is going to be good enough. But finally, I'll just say this. Notice how they do show you, once they do put all the relative frequencies, how they do show you that it does add up to 1. And just to kind of keep going, here was your frequency distribution converted into a relative frequency. So here was, they had the 8 different classes, the frequency counts, and then here again is the relative frequencies. You just take 8 divided by 180. Of course, they're showing that over here, but I just try to give you some more step-by-step instruction. It's really that simple. Take each one of these divided by 180, you get your relative frequencies, and then show that it adds up to 1. And on this particular slide, they're just showing you some different ways other than the tables and the distributions of how you could graph some of these. This one up here, by the way, you'll notice that looks a lot like a bar graph. It essentially is a bar graph, but the only difference is notice all the bars are bunched up together and there's no spaces. So think of a bar graph as basically it's like a histogram, but the bar graph has spaces between the bars. A histogram does not. Okay. And down here you've got a line graph, a couple line graphs, just to kind of give you some different views on how you might want to, options on how you might want to present data. And again, here is, precisely the definition of your histogram, and just notice it's basically, your bar graph with no spaces. Okay, last couple things in this chapter you want to know is how to do what's called a cumulative frequency distribution. And a cumulative frequency distribution, basically, for example, you start with the first class. In this case, the top number was 600. And it's like you're saying less than or equal to the upper limit for each class. Notice it says less than 600, less than 1,000. So you can say less than or equal to, I like to say less than or equal to 1,000 and so forth. Okay? But basically what you do is you start with the first one. The frequency is 8. Okay, and then when you go to the second category, all you do is you keep adding the next layer. So if the first category was 8 and the second category was 11, so you would have taken 8 plus 11 and that would have given you 19. Okay, and then you basically keep adding on a layer. So the next one was 23, so we would have had 8 plus 11 plus 23 would get you to 42. So think of every time you go to the next layer, it's always going to be less than the upper limit number. And so eventually what happens is when you get to the very last class, which is the largest number, was the top was 3,400, notice that this number right here is equal to 180 vehicles. So basically the very last class should be 100%. That should be all your numbers.